Okay, then now we can briefly talk about some business opportunities and the future directions of additive manufacturing. Let me start with the next generation additive manufacturing factory layout. And some companies like G and EOS are working on such kind of concepts. Let me show you in a moment. Any questions, by the way?
Together with our partners, Premium Aerotech and Daimler, we move forward, seamlessly integrating industrial 3D printing into serial production. This is how concepts become reality, shaping the production site of tomorrow, expanding our product portfolio with automated manufacturing solutions. One central material depot automatically supplies several additive manufacturing systems.
So you don't need to have separate, let's say, powder hoppers. They have a huge system, and it's giving powders to all machines.
By automating and parallelizing process steps, the production efficiency is maximized. In-sync working ultra-fast quad laser systems significantly increase productivity.
And these days, even these companies are working on systems having 16 number of lasers. With the help of it, they can decrease the fabrication time and have many other properties with the help of these multiple lasers.
Optimized process parameters enable components fit for purpose. Automated processes for the removal and transport of building platforms increase efficiency. Powder and parts are separated automatically, returning the material to the material cycle. After the automated removal of parts and the subsequent heat treatment, a geometric quality assurance takes place. Finally, the parts are separated from the carrier plate. The quality assured and separated parts are available. The future is now. Be part of the next generation of manufacturing with EOS Industrial 3D Printing Solutions.
So this is how we are expecting such companies evolving in near future. Any questions, guys, about this concept of EOS? They're going to have, not now, but maybe in, as I said, most of the time, in 10 years, 20 years, they may have such factories composed of only additive manufacturing systems. They have, as you see, special material delivery, special recycling processing systems. So things will be much easier for additive manufacturing in the upcoming years. But right now, what we are doing, if you consider the conventional manufacturing companies, they're always trying to do a central product development, central manufacturing and distribution. So they have a huge factory at some location of the country, and then distribute these materials to other places in the same country or in the same continent. But with additive manufacturing, we can have more production places, less distribution, and this will always increase the sustainability of manufacturing. This is the kind of trend in manufacturing. We are trying to decentralize manufacturing and distribution. We will have many production facilities in each, let's say, smaller cities, and have less distribution. This will result obviously in less labor costs, less resource costs. It will be a much more sustainable manufacturing process. So as I said, in additive manufacturing, we don't need to have a central development. Any individuals or communities having kind of printers, additive manufacturing machineries can print, can fabricate the designs. And with the help of them, they may focus more on the conceptualization. They focus more on the new designs, new products, create on their own, and then they can easily propagate their design. So what they need to do, they can simply upload their design on such websites, and then with the help of them, it can be distributed to anyone in the world. So what about, let's focus on these product conceptualization. With the help of this one, obviously we can have some brainstorming sessions. You can collect ideas from different people, and instead of having a centralized brainstorming sessions, we can have online sessions and try to do this conceptualization in a global manner, and we can make use of these advantages since different type of people in world may have various ideas. With the help of them, we can have a proper conceptualization of your initial idea. And for the designs, if you remember from our specific mass customization examples, scanning can be used to actually collect various data for various physical features from people. And for the product creation, we can use some web software like Tinkercad or SketchUp. They're all simpler CAD software, but each day they're adding new features to their software, and maybe again in some few years we can have powerful CAD software online. And for the propagation, you can store your designs on such websites. There are many of them. These are the things, actually the websites came to my mind, and I've written it here. And for the propagation, again, you can use the same websites. Or for building, we have a website called, like, there are many of them, but the first one was 3D Hubs. So you simply upload your design there, and then they try to find you a manufacturing facility which is close to your, let's say, location, and then it can easily be manufactured in that facility and distributed to you. So this is kind of an way of digital entrepreneurship. So without using let's say, a conventional factory, conventional manufacturing facilities, you can easily fabricate your ideas, design your ideas, and then make them visible, and you can easily distribute them with help of this website to anyone in the world. And digitalpreneurship is actually coming from digital data, transforming digital data into physical products using an entrepreneurship business models. And this 3D Hubs is a nice example for that. They don't have any, the company itself, I think, don't have any manufacturing machineries. They are only producing a kind of a service for different customers. We have many examples in world. You can consider Uber or other kind of Uber Eats, Yemek are kind of digital entrepreneurship examples. So we discussed all these, and with the help of such systems, such let's say websites, such digital entrepreneurship companies, we can have customized, localized, and event-based products which are obtained in a shorter time and at lower costs. And once we have more developments in additive manufacturing and other communication technologies, such scanning technologies, we will have much more companies based on additive manufacturing in near future, like, for instance, specialized shoes, specialized watches, other kind of personal products. They all will be possible in upcoming years, and they will have superior characteristics. Since we are making use of additive manufacturing technologies, you can have lattice structures, you can have different materials inside your product, so the resulting products will have superior characteristics compared to the conventional products. But obviously there are some disadvantages of AM. You need to consider it and try to come up with a proper way. And with the help of additive manufacturing, you can decrease your overall material consumption. You don't need to have factory equipment. You don't need to have the factory itself. The space is not required. And with the help of it, you can have more opportunities to distribute your designs, ideas to many people around the world. And lastly, you can produce on demand. You don't need to produce in advance and store them in your shelf. Instead, once you have a kind of an order, you can directly print your product. Here you see some reductions, radical reduction in the consumption of non-value-adding resources, like you don't need to have molds, dies, you don't need to have any assembly process, you can decrease the number of parts, you don't need to just store the spare parts in your company. Instead, once they're actually ordered, you can directly fabricate and then send these spare parts to your customers. You can have a look at first order and second order effects, but the main things are written on this first column. And with the help of these technologies, we can easily have new types of products. With conventional things, it's quite difficult. You need to spend more time on designing, more time on manufacturing if you follow the conventional manufacturing pipeline. But if you are using additive manufacturing pipeline, then new types of products or new ideas can easily be produced, and you can start earning money out of these products. So we have another term called digipreneur. Digipreneurs are people who are creating digital tools for other digipreneurs or other customers. They have designs, special designs. They may be just selling the designs, not the product itself. Or some of the digipreneurs might be turning these designs into physical products, or they may be just selling their licenses or software to companies or other people. So in near future, we will have new types of employments since the paradigm is shifting from conventional manufacturing to additive manufacturing. We will have new types of people, new types of employment in such industries. The energy consumptions will be decreasing since we don't have transportation a lot. People will be producing their products in the facilities which are closer to their home, closer to their offices. And these are examples. We don't have much time, so you can have a look at them. We have a nice example of Finland. Although they have limited resources, although they are away from huge markets, mass markets, have all high labor costs, they actually make use of communication technologies with additive manufacturing to overcome these disadvantages. We can have a look at the details of their story, and it's a nice success by using additive manufacturing and communication technologies at the same time. So what are the important resources in digital entrepreneurship? You need to have creativity. You need to be aware of all the technological improvements in your field and other similar fields. You need to be inside a network between digipreneurship members, companies. If you have all these, then you can be an digipreneur and try to produce new types of products. And if you make use of additive manufacturing and other communication technologies, then obviously the labor cost will be much less compared to the conventional manufacturing and conventional way of producing new products. So you can easily combine these high technologies and have much better results. I'm skipping these, but make sure that you go through the chapter on your textbook, read all these related parts. And these are examples of new types of employments related to additive manufacturing and some other Industry 4.0 technologies. You'll have IT people, you'll have, we'll be removing some conventional manufacturing shops, but instead have additive manufacturing facilities. Oh, any questions, guys? I'm skipping these. Make sure that, as I said, since you'll have quizzes on these next week, make sure you go through them and have a look at the textbook. There are related chapters on these. And I think we can call it a day if you don't have questions.